Hi friends, I am Sunil working as BSNL JE. Welcome to BSNL JE 2016 exam preparation. In this video, I am going to discuss remaining topics of electrical specialization. Dual converter. Dual converter. As name itself, it is a combination of rectifier and inverter. It is a combination of rectifier and inverter. That means it converts AC to DC and DC to AC also. Okay, dual converter is a combination of rectifier and inverter. That means for rectifier it has one bridge, for inverter it has one bridge, so totally it has two bridges. It have two bridges. It consists of two bridges consisting of thyristors in one in which one for rectifying and another bridge for inverting. That means it has two converters. First converter is for rectification, converter 2 is for inverting. Okay, for example, single phase dual converter, it has converter 1 rectifier, converter 2 inverter. Okay, inverter 2. And coming to the principle of operation of this dual converter, converter 1 is used to rectification, that is it converts AC to DC, and converter 2 is used to inversion, that means it converts DC to AC. It converts DC to AC. And applications of this dual converter, the dual converter has wide applications in speed control methods, speed controls and direction control of DC motors, speed control and direction control of DC motors. That means these are used wherever the reversible DC voltage is required. These are used in wherever reversible DC is required. So the dual converters has wide applications wherever reversible DC is required. And dual converter is also called as 4-quadrant converter. Dual converter is also called as 4-quadrant converter. That is because it operates in all 4 quadrants. It operates all 4 quadrants. It operates in all 4 quadrants. And next one, cycloconverter. Cycloconverters are nothing but AC to AC converters. Cycloconverters are nothing but AC to AC converters. That means they convert AC at one frequency to AC of another frequency. Cycloconverters converts AC at one frequency to AC of another frequency. That means they are changing the frequencies. Cycloconverters are mainly two types. These cycloconverters are mainly two types. First one is step down cycloconverter, second one is step up cycloconverter. Step down, that means the output frequency is less than that of supply frequency. It steps down the frequency. That means F0 is less than Fs, that is output frequency is lower than the supply voltage. That means these cycloconverters steps down the supply frequency. That means output frequency F0 is less than Fs. That means output frequency is lower than that of the supply frequency. Step up cycloconverter, this means step ups the supply frequency. That is output frequency is greater than the supply frequency. Output frequency is more than the supply frequency. And coming to the applications of the cycloconverter, cycloconverters are used wherever the frequency changes are required. For example, electro locomotives, that is railways, electric railways, electric locomotives, and induction heating. In case of induction heating, we require higher frequency, so we use step up cycloconverter for this. Okay, and the speed control of high power AC drives, and aircraft and shipboard power supplies. Okay, and next one, AC regulators. AC regulators or AC voltage controllers. AC regulators. That means the AC regulator is a device which converts fixed AC voltage into variable AC voltage without change in any frequency. Without change in frequency. That means AC regulator is a device which converts fixed AC voltage into variable AC voltage. Fixed AC voltage into fixed AC to variable AC, and here frequency is constant. Frequency is constant. And applications of this AC regulators for transformer tap changing, and speed control of single phase and three phase AC drives. Very important. AC regulators are mainly useful in speed control of single phase and three phase AC drives. And starting of induction motors, these are used for starting of induction motor. Actually the induction motor is not self starting, so to start the induction motors we require AC regulators. And lighting level controls, for lighting level controls these AC regulators are used. Starting of single phase induction motors. Okay, next, power electronic applications in drives. Actually the drives are mainly DC drives and AC drives. DC drives and AC drives. The power electronic applications in drives means power electronic applications in AC to DC drives. We have DC supply. For AC to DC drives, if we have AC supply but we require DC supply, for in this case these AC to DC drives are employed. In that case AC to DC drives are employed. In this AC to DC drives, the power drives converts AC to DC by using these power electronic devices. That means in case of AC to DC drives, to convert AC to DC, these power electronic devices are used. Okay, for example, in a single phase converter, that is in single phase AC to DC drives, it is a motor, and this power electronic device is connected. That is, it is nothing but AC to DC means rectifier circuit is connected to this motor, and if we give the AC supply, it will convert AC to DC, and this DC supply is given to the motor drives. And this output, the output from rectifier V0 equal to 2 Vm by pi cos alpha. By changing this firing angle, we can control the output voltage. In case of three phase, this is a three phase rectifier, and it is connected to the motor which is required DC voltage. For this three phase AC is converted to DC, and this DC is given to the motor, and the output of this three phase converter V0 equal to 3 Vm by pi cos alpha. These are nothing but AC DC drives, nothing but rectifier drives. And DC to AC drives, nothing but inverter drives. DC to AC drives, we have only DC supply, but we require AC supply. For this, in this case, the DC to AC drives are required. These are these inverter drives converts DC to AC, and the AC is given to the motors for controlling purpose. Some electrical drives require controlled AC supply. For that purpose, DC to AC drives are required. Okay, and AC to AC drives means nothing but voltage regulators and cycloconverters. These drives are used wherever variable or controlled AC requires. Variable AC or controlled AC requires. These drives are mainly used for speed control of motor drives. And the chopper drives, DC to DC drives, we have fixed DC voltage but we require variable DC. In that case, this DC to DC drives are employed, that is chopper drives are employed. These devices are used wherever variable or controlled DC required. Wherever variable or controlled DC requires. That means the choppers have applications in these DC to DC drives, these DC to DC drives. Okay. And next topic, refrigeration and air conditioning. Refrigeration and air conditioning. First of all, what is refrigeration? Refrigeration is a process of moving heat from one location to another location. Moving heat from one location to another location. Once again, refrigeration is a process of moving heat from one location to another location. That means heat removed from this first part and it is transferred to another part. That means here heat is removed. That means here it is a colder. It becomes a colder. Okay. Likewise, the refrigeration process performs. Okay. Methods of this refrigeration. First one is non-cyclic refrigeration. Actually, the heat transfer from hot to cold side. Hot to cold side. Generally, heat transfer from hot to cold side. But in case of refrigeration, some work will be done. Heat transfer from cold to hot side. Then the heat removed from cold temperature and it is transferred to heat side. Then the cold will becomes colder, very cold. Okay, by removing heat from this side and transfer to another side means it will become more cool. Okay, the refrigeration methods are nothing but first one is non-cyclic refrigeration. Non-cyclic refrigeration, that means it is not a cyclic one. That means this method cools a contained area by melting ice. It cools a contained area by melting ice. For example, it is a portable cooler. That is nothing but where the items are put in a container, and that container will be filled with ice. Filled with ice. Then the items will be cooled up by using the ice temperature. Okay, this is a non-cyclic refrigeration. And cyclic refrigeration, this consists of a refrigeration cycle. Refrigeration cycle means heat transfer from cold side to hot side. Hot side, and the cold side will becomes cooler. This consists of refrigeration cycle where heat is transferred from one temperature to another temperature. That is, heat is removed from low temperature space and rejected to higher temperature with the help of some external work. That external work will be done by refrigerators. That means the refrigerators take heat from one temperature space to and rejected to another temperatures. Okay. And thermoelectric refrigeration, next method, thermoelectric refrigeration. In this method, it uses a Peltier effect to create a heat flux between the junctions of two types of material. That means it uses a Peltier effect to create heat flux between the junctions of two types of material. And next refrigeration method is magnetic refrigeration method. It is based on, this cooling technology is based on magnetocaloric effect. And next one, air conditioning. Air conditioning is nothing but it is a process of altering the properties of air. To more comfortable conditions. That means an air conditioner is a device that removes heat from air inside a building and sent that outside, thus lowering the air temperature. Here one building is there. In this building, air conditioner is there. This air conditioner removes heat from that room and it's sent to outside. Then the heat will be reduced and this room will become cooler. Okay. In this way, the air conditioner performs. That operating principle of air conditioning is refrigeration cycle. Refrigeration cycle, we know that refrigeration cycle means heat transfer from cold or low temperature to hot, that is high temperature. Okay, this is a refrigeration cycle. The operating principle of air conditioning is refrigeration cycle, that is heat transfer from a colder location to hotter location. Okay friends, thank you. In next video I will discuss remaining electrical topics. Okay, thank you.